Artemis II is getting closer, and soon 4 astronauts will travel around the moon for the first time in more than 50 years. But if you've been following the news, or even reading the comments online, you'll notice something interesting. Some people are worried the mission might be too risky. Others are saying there's nothing to worry about at all. So what's the truth? In this video, we're going to break down the real concerns around Artemis II and what NASA is actually dealing with right now. And also clear up some misunderstandings that a lot of people are getting wrong. Because spaceflight is never simple, and the reality is more balanced than the headlines or comment sections might suggest. So let's first talk about the mission. Artemis II will send 4 astronauts, Reed Wiseman, Victor Glover, Christina Cook and Jeremy Hansen, on a journey around the moon and back. The spacecraft they will fly in is called Orion, launched on NASA's Space Launch System, or SLS. This mission won't land on the moon. Instead, it's a critical test to prove that Orion can safely carry humans into deep space and bring them home. If Artemis II succeeds, it clears the path for Artemis III, and this is the mission to land astronauts on the lunar surface. So this flight is a major stepping stone, guys. The biggest technical concern being discussed right now is in Orion's heat shield. When a spacecraft returns to the moon, it enters Earth's atmosphere at around 25,000 miles per hour. At that speed, the air in front of the capsule compresses and heats up to roughly 5,000 degrees Fahrenheit. That's about half the temperature of the sun's surface. To survive that environment, Orion uses an ablative heat shield made from a material called avcoat. Ablative means the material slowly burns and erodes away, carrying the heat with it. During the uncrewed Artemis I mission in 2022, the heat shield did its job and Orion returned safely. But engineers did notice something unexpected. Some areas of the heat shield experienced deeper erosion and larger pieces of material broke away compared to what computer models had predicted. NASA's analysis later suggested the crew likely would have survived that re-entry, but in engineering, unexpected behaviour is taken very seriously because when humans are involved, probably safe isn't the standard. Now this is where a lot of people online are getting confused. You'll often see comments saying, "We bring astronauts back from the ISS all the time, re-entry isn't new." And that's very true, but there's a critical difference here. Astronauts returning from the International Space Station re-enter Earth's atmosphere at around 17,500 miles per hour. Artemis II will return from the moon at 25,000 miles per hour. That extra speed increases the heat dramatically. The energy involved in re-entry rises the square of velocity, which means lunar returns are in a completely different thermal environment. So while low Earth orbit re-entry is now routine, lunar re-entry is far more demanding, and that's exactly why Orion's heat shield performance is being examined so closely. If the heat shield didn't behave exactly as expected, the obvious question is, why not redesign it before Artemis II? The answer comes down to time and mission delays. A full redesign would likely push the mission back by years and add significant cost. Instead, NASA is changing how Orion comes back to Earth. For Artemis II, the spacecraft will follow a different re-entry profile, one that reduces the amount of time the heat shield experiences extreme heating. The idea is to avoid long duration heating that contributed to the unexpected erosion during Artemis I. Some engineers believe this is a reasonable solution. Others argue that the underlying design should still be improved. And NASA has already confirmed that future missions, including Artemis III, will include heat shield improvements. Another very common comment is, "We went to the moon in the 1960s with less technology. Why is it harder now?" The short answer is, the risk tolerance has changed. During the Apollo era, NASA accepted much higher levels of risk. After the Challenger disaster in 1986 and the Columbia disaster in 2003, NASA completely changed its safety culture. Today's missions require extensive ground testing, independent safety reviews, detailed risk analysis, and much higher reliability targets. So it's not that we've lost the ability to go to the moon, it's that the safety standards are far more strict than they were during the Apollo missions. It's also important to understand something else. Human spaceflight is never risk-free. NASA doesn't promise that Artemis II is perfectly safe. What they do is risk management. Every system is tested, reviewed, and analysed to reduce the chance of failure as much as possible. That's why delays happen, and that brings us to another area NASA is working through right now. Before a launch, NASA performs what's called a wet dress rehearsal. This is a full countdown and fueling test without astronauts on board. During the recent Artemis II rehearsals, engineers ran into several issues: cold weather delays, a hydrogen leak, communication dropouts, and monitoring gas buildup near the crew module. None of these problems are unusual for a rocket this complex, but each one has to be understood and resolved before NASA commits to a launch date. Because once astronauts are sitting on top of the rocket, there's no room for uncertainty. Even after technical issues are resolved, launch timing depends on several factors. The Earth and Moon have to be in the right positions, weather conditions must be safe, and Orion's solar panels need enough sunlight during the mission. Plus, the trajectory has to allow for a safe re-entry and splashdown. That's why launch opportunities come in short windows, and why delays of weeks or even months are normal. So where does all this leave us? Here's the honest picture. Artemis II is not risk-free, but it's also not reckless. Most experts believe the mission is likely to succeed, and the concerns being discussed, the heat shield, the testing, the rehearsals, are actually signs that NASA is doing what it is supposed to do. They're identifying problems and understanding them, and reducing risk before anyone leaves Earth. And there's another reason Artemis II matters so much. This mission isn't just about flying around the moon. It's about proving that NASA can safely operate in deep space once again. Everything about Artemis II pushes beyond what we've been doing for the last 2 decades. Since the space shuttle was retired, most human spaceflight has stayed close to Earth, operating in low Earth orbit. But the moon is a completely different environment. Astronauts will be farther from Earth than any crew since Apollo, outside the protection of Earth's magnetic field. They're going to be exposed to deeper space radiation, and completely dependent on Orion's safety systems for survival. There's no quick rescue from the moon. If something goes wrong, the spacecraft has to handle it on its own. That's why this mission is so important. And it's not just a test of the rocket, it's a test of life support, navigation, communication over long distances, power systems, and Orion's ability to bring a crew home safely from deep space. Because if Artemis II works, then Artemis III becomes possible. And that's the mission plan to land humans back on the moon, not just for a visit, but as the first step towards a long-term presence. And that's really what the Artemis program is about. Not repeating Apollo, but building the foundation for future missions, including Mars. So yes, Artemis II carries risks, but it also represents something much bigger: the return of human exploration beyond Earth orbit. And if NASA gets that right, it won't just be another mission. It will be the moment deep space human flight truly begins again. And that's why it's important to look at Artemis II with a balanced view. There are real risks, there are real technical challenges, but there's also an enormous amount of testing, engineering, and experience behind this mission. Space exploration has never been about eliminating risk completely. It's about understanding the risks, managing them, and moving forward carefully. Because every major step in human spaceflight has come from doing exactly that. And if Artemis II succeeds, it won't just prove that Orion and SLS work, it will prove that we're ready to move beyond low Earth orbit again and take the next step towards a permanent human presence on the moon. So let me know what you think in the comments, guys, how you think this mission is going to unfold. We've got some exciting times ahead. Anyway, thanks again for watching, and I'll see you in the next one. Take care.